Hey, welcome back. 1998 AP Calculus AB free response question. We're going to go over number 2. All right. For the 1998 exam, all 6 questions are in one part. It's section 2. There's not a part A and part B. All right. And you get to use a graphing calculator for every single one of them. So our setup of each problem is critical because our calculations can be done using the graphing calculator. Let's begin. We did in our last video problem number 1. We are on to problem number 2. Number 2 says, let f be the function given by f of x equals 2x e raised to the 2x. All right, and part A is asking us, okay, to find the limit as x approaches negative infinity of f of x, and to also find the limit as x approaches positive infinity of f of x. So let's go ahead and, ooh, fancy. Let's use it. We're going to do part A right here. Part A. Okay. All right, so the limit, let's start with the easier one, is x approaches infinity of f of x. Okay, so it's 2x e to the 2x. All right, well, I'm just going to plug in an infinity, so to speak, and ultimately I have 2 times infinity, which is infinity, and times e to the 2 times infinity, which anything raised to infinity will go to infinity, and I'm just going to end up with infinity for this first one. That's my response, okay? They're asking us for a value, so I tell them infinity. If they were asking me for a horizontal tangent line, I would say there is none. But they are not asking me for the horizontal tangent line. They're asking me for the value, and it's infinity. All right, the next one now, negative infinity. Oh, it's a nasty mistress. And why is this going to be any different? Okay, I'll explain in a moment. 2 times negative infinity, okay, e to the 2 times negative infinity. Now here is that negative sign right there. It's a bad negative sign. Remember, anytime there's an exponent that's negative, we must flip it. So I now have in the front 2 times infinity, well, 2 times negative infinity. I guess it's negative infinity all over. Now I have e, okay? My infinity will now be positive in this exponent. And you might say, well, what happened to the 2? 2 times infinity is still infinity. Now, in case you didn't know, infinity is an exponent to a base of a number larger than 1, okay, and e is 2.718. An exponent will grow faster than just counting by ones, which means the bottom will get bigger and bigger and bigger, more so than the top will. So this will actually approach 0. All right, so that's the catch here. That's the catch 22 for A, that negative infinity. So we're done. 2A is done. This is good. This is good. B says, find the absolute minimum value, okay, the absolute minimum value of f. Justify that answer as an absolute minimum. Okay, so what we're going to do here is there's 2 things I can do here. Number 1, I can graph this, but they want us to justify, so we're going to have to show some sort of math work afterward. But truth be told here, let's view, do I have a detached LCD? There it is. Woo! There was an update to the computer. It's fancy now. So what I'm going to do is I'm going to go to y equals, and I'm going to graph f, okay? 2x times, I guess we'll say e raised to the 2x, all right? And I'm going to graph this bad boy. Let's see what it looks like. Let's see what this bad boy look like there. Oh, there's a little dip. So it looks like the minimum happens right around here. So in my calculator, Okay, in my calculator, I am going to go second trace, and I'm going to put minimum. And I'm going to do a little bow tie. I'm going to move my little spider dude here to the left. I'm going to move my little spider dude up here to the right. And I hit enter one more time. So my minimum happens when x is approximately -1/2. Okay, but my y value is going to be -3.6. That will turn into an 8 because the number after it is 5 or bigger. So 1/2, -368. Here we go. So right now for B, I know it's at -1/2, -0.368. So this is the min point. This is where it occurs. This is the actual minimum, the y value. I like the calligraphy pen so much better. We got to justify this with math work. Remember, we can use first derivatives to find mins and maxes, okay? So the first derivative of f of x is, product rule. First times the derivative of the second. The derivative of e to the 2x is 2e to the 2x. Plus the second, e to the 2x, times the derivative of the first, which is just 2. Okay? Now, I want to see, all right, I want to see where that equals 0. Okay, that's going to be a critical point. So I'm going to set that equal to 0. Let me clean this up. I'm going to have 4x e to the 2x plus 2e to the 2x equals 0. Okay, I mean, if I wanted to, and I'm going to make this a little bit easier, I'm going to factor out an e to the 2x from both of these. So I've got e to the 2x times 4x plus 2 equals 0. This will never equal 0. So I only need to see where this factor equals 0. Okay? And that happens when x is -1/2. Okay? If I solve that, I say 4x plus 2 equals 0. I subtract 2 from both sides and get 4x equals -2. And then I divide both sides by 4. That happens at x equals -1/2. That's good. That confirms what our calculator told us. Well, then why are we doing this math? This word right here. We need to justify it. Okay? I don't know on a calculator if sketching the graph would be justification. Maybe it would be. But I'm going to do this algebraically just to check. So it happens here. On my number line, here's where x is -1/2. Here's my derivative. I know that equals 0. I'm going to pick a number on both sides. How about 1 and 0? Remember, if that's a minimum, I want it to have a negative derivative or slope to a positive derivative or slope. If I plug 0 into my derivative, okay? If I plug 0 into my derivative, yeah, I'll be okay. I'm going to have to use 0 would be right here. I'm going to use -1. Sorry. Okay, so I'm going to use -1 and +1. If I throw a -1 into my derivative, I will get a negative answer. I put a -1 here, that gives me -4. -4 plus 2 is still negative, so I get a negative value. Okay? What happens if I throw a 1 in? Well, if I throw a 1 into this x, I get 4 times 1 is 4 plus 2, that's a +6. Okay, so it's positive. So there you go. That's confirmation that it works. And now all I got to do is figure out, well, what is my f value? I want the actual y value. Okay, whoop. There. I want to figure out my y value, and I'm going to plug in -1/2 in for these x's. Okay? So f of -1/2, I mean, we already figured that out. It's approximately -0.368. Minimum. There you go. So there you go, minimum. Find the absolute minimum, there it is. We're good to go. C. What is the range of F? What is the range of F? Well, I like when we have problems that we can go back to a previous part, A, B, or C, and use it. If I know, okay, if I know my absolute minimum or lowest point is negative 0.368, and it only goes higher from there, my range goes from negative 0.368. We're talking about our y's, or our f of x's. So you can put a y here, or you can put f of x here, and it goes up forever. I can do that. Or I gotta say negative 0.368, comma, to infinity. I use a parenthesis here, and because I include this, I use that. I can write that either way. That was nice. That was real nice. All right. Last one. That was good to get a nice break there. I'm going to be honest with you. Let's go with the fourth color, black up there, D. Consider the family of functions by y equals bx e to the bx, where b is a non-zero constant. Okay, so this is going to be a number. Just like in the previous previous section, or actually in the beginning, it was a 2. Okay, right here it was a 2, our b value. Okay, show that the absolute minimum value of bx e to the bx is the same no matter what b is. So for all non-zero values of b, our variable b can be any value as long as it's not 0. All right? All right, well, this is going to require some algebra, but, you know, that's what we're here for. Calculus is algebra heavy, so D, I will do that right here. So we start with this, equals b to the x, e to the bx. All right? And in order to find minimums, right? In order to find minimums, because they're asking us, show that the absolute minimum is the same. Okay? So I need to take the derivative. So, again, we're going to do the product rule. The first times the derivative of the second. Now, we already took the derivative. We took the derivative right here, and we simplified it. We ended up with this. Here's the derivative. Okay, and we simplified it, didn't we? So for every 2, instead of a 2, I'm going to put a b here, because we have b's instead of 2's, okay? So I'm going to have a b here, going to have a b here, going to have a b here, and this is going to be 2 times b, okay? 2 times b. Or I guess it can just be, b squared, b times b. Let's start with this one and put a b in for every 2, all right? So here we go. We have bx, that's going to be a b, bx, times b e to the bx. Sorry, I'm writing down here in the bottom of the screen if you can't see it. Okay, plus e to the bx times b. Okay. Let's get some space here. All right, so b times b is b squared. We have our x, e to the bx, plus b times e to the bx. All right, that's our derivative cleaned up. Let's factor out, okay? Let's factor out what we can right here. I can take out 1b, and I can take out an e to the bx. What that leaves me with, okay, I still have a b left. If I take 1b out, I have a b. I have my x. The e to the bx is factored out. Plus Okay, oh, look, I take out everything, b and then e to the bx, so that's just going to be a 1. All right? Now, minimums happen when my first derivative is 0. Okay? Again, this will never be 0. It doesn't matter what you make an exponent. Okay? That will never be 0. So, where does this happen? When x equals, well, I'll solve it, negative 1 over b. Remember, our b is 2, right? Didn't it happen at negative 1/2? But our b's are 2. If you need to see this algebra work done, I'll do it over here. I have b to the x plus 1 equals 0. I subtract 1, so I got b to the x equals negative 1. Then I divide by b. Bam, divide by b. This is the place right there where my minimum occurs. All right? We know it's a minimum because we know what the graph looks like. All right? It kind of comes down like this, comes down, and comes up forever. There is our minimum. All right? So now, in order to find the actual minimum, this is just where it occurs. In order to find the actual, I need to find the y value. I need to plug it into the original equation. Okay? So I'm going to take my original equation and throw in a negative 1 over b. So let's do that. I'm going to go all the way back to the original equation. Okay? This thing right here, the original equation. And in for my x, which would be here and here, I'm going to throw in a negative 1 over b. Here we go. So I have b times x, which is negative 1 over b, times e to the b times x, which is negative 1 over b. All right, well, let's clean this up. Let's clean this up, shall we? All right, when I multiply these together, these cancel, and I have negative 1. All right, same thing when I multiply these together and get negative 1. Remember, negative exponents flip. Negative 1 over e to the 1. That is my y value. That will never change no matter what b is. How come? There's no b left to affect it. There's no b left to affect that. That will always equal negative 1 over e. Always. Guess what negative 1 over e equals? Should we check that on our calculator? And you might say to yourself, why I don't get that? Because remember, that was our minimum. That was our original minimum. It should always be the same. So right now, this is what, ooh, that's my y value, not my x value. Negative 1 divided by e. There it is, negative 0.36, and that will round to an 8. We're good. Whew! There you go, but this is it. It will never be anything different, ever. All right. Almost 20 minutes. We're at 19 minutes. Good, 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 good. You can rewind this, watch it as much as you want. That's why I do these things. But that's a lot of work. That's good. Now, keep in mind, for the 1998 test, okay, every problem gets a calculator, which means the problems are going to be a little bit more, complicated. They're going to be a little bit more involved. But you have the calculator, so they are going to show more work here. But that algebra work, you can use a calculator for. All right? Like this video. Okay, again, liking these videos only helps me. All right? I'm trying to help you out. So guess what? You trying to help me out. Also, follow me, because I'm about to put up the video for question 3 in the very near future, and you want that notification when I do it. All right? See ya. Good work as always, and we'll be talking again for problem number 3.